Hi everyone, welcome to the 3113 E-Conduction Lab walkthrough. What we'll be covering is actually the software procedure, the hardware procedure, and then I'll be covering what the actual hardware looks like for the lab. So I've got right here an actual sample that I've pulled out of its casing. You can see the casing here, and then the kind of mylar bubble wrap that we use to keep it thermally insulated. And then if I get this pulled out, get it close to the camera, you can see each of the different K-type thermocouples that we actually bolted in across the sample so that you can get the different thermocouple temperatures at different locations. What you can see here is the water supply that we use to actually send and receive water and circulate through it. And then here's the actual K-type thermocouple junctions, and then the power supply, or how we connect to the power supply. So if I set that aside, we can come over to what a setup sample looks like, which is over here to my left. So right here we've got the power supply the water supply hooked up. We've got the power supply running over here, and then we've actually got the K-type thermocouples plugged into a control box, which is talking to a lab VI on the computer, which is all set up through a USB. We've had this water actually running through it for a while because you need to actually let the system cool down so it reaches a steady state, so that we have a good starting point before we get the actual lab running. Over here, I have the power supply off. That's because I don't want to actually start heating the sample yet, because we need to get 10 steady state cool samples in the actual data log before we get running. So with the VI open, with the power supply on, and I know the amperage that it's going to start outputting through the setup procedure, I can actually hit the run button on the VI, choose my data sample, and replace it. And then what we'll wait for now is another 10 samples to actually be recorded, so that we have a good baseline to work with during our data analysis. So we'll wait for those 10 samples to be recorded, and you can see we've already recorded 2 of them. And then once that actually reaches the 10 sample point, I'm going to turn on the power supply and let the thermocouples start heating up. Or I guess the heaters start heating up and let the thermocouples record that heat. Once we reach 10, we'll cut the video and we'll come back once we have some more data. Alright, so we've reached our 10 sample mark. So we have a good baseline. So now I'm going to actually turn on the power supply. The heaters will start receiving a little bit of power and they'll start heating up. At that point, we can see over here on the screen, once a few data samples get going, it'll actually start ramping up in the temperature. And we have about 2 hours ahead of us, maybe 3, to actually reach the final heated steady state values. So once we get there, we'll come back with the video and hopefully we'll have some good data.
Hello everybody, we are back to take a look at the final results that have come out of this test. As you can see here on the plot, we were at steady state right at the beginning and then went through a transient heat change and now are getting to a steady state. This particular test has come out with some variations in temperature at steady state, so this is not data that would be good for analysis, but when we post the data for you, it should have a smooth and level steady state, and you should be able to get good information off of that. So once you're done getting to steady state and you're pleased with your results, you can go ahead and hit stop and save here on the computer. Make sure to always hit stop and save instead of stopping the VI directly. This will then save your data and you can use it for analysis.